unfold.
Okay, let's get into this. For, more than 25 years now, there's been this one single cultural touchstone for our fears about bioethics.
Yeah.
I'm talking about the 1997 film Gattaca.
It really is the perfect shorthand, isn't it? Everybody knows it. This idea of a society where your whole life is basically mapped out by your genome.
Right.
You've got the faith births on one side, the ones born the old-fashioned way, taking their chances with a genetic lottery.
Right.
And then you have the elite, the optimized, scientifically managed kids who get a perfect start. It was always meant as a warning, about some far-off future.
And that's the thing. What our sources are confirming, and this is why we wanted to do this deep dive for you, the listener, is that far off isn't so far off anymore. It's here.
It's here now.
That premise, the whole idea of a society split by the quality of your DNA, it's rapidly moving from a movie plot to a commercial product.
Yeah.
And the main technology driving it is called polygenic embryo screening, PGTP.
The message is, it's pretty stark. The whole era of genetic luck, that random biological hand you and I were dealt, it's basically ending.
And what's replacing it is, it's a system, a really deliberate and frankly expensive system of genetic choice.
Exactly.
So what's making this possible right now? Because we're not talking about editing genes in adults. This is something else. It's a convergence, right?
Yeah, absolutely about convergence. You need three specific things to come together.
Yeah.
First, you need mature IVF technology so you can get a pool of embryos to choose from.
Okay.
Second, you need genomic sequencing that's fast and relatively cheap. And third, you need the massive statistical power of these new algorithms, the Polygenic Risk Scores, or PRS.
Right.
And what's so critical for you to understand is that the reality right now isn't some dramatic gene editing fantasy that's still, way down the road, ethically very messy. The reality today is selection.
Okay.
Picking from what's already there, selecting from a batch of existing embryos based on this complex statistical crystal ball of their future potential. It's exact.
In the industry, they market this as purely preventative medicine, right? Let's reduce the risk of type 2 diabetes or breast cancer. But the sources are crystal clear on this. The infrastructure they've built is, it's fully capable of and maybe even aimed at enhancement.
That is the essential insight here.
Mm-hmm.
Think about it. The moment you can screen for the genetic liability to, say, intellectual disability, you're already playing on the same field as screening for high cognitive ability, for a high IQ.
Just the same continuum.
It's the exact same continuum. We're talking about screening for height, for certain cosmetic traits, and the most controversial one, for intelligence. We've moved past just diagnosing a problem to get rid of it.
Yeah.
Now we're comparing and ranking possible human futures.
So our mission today is to really pull the curtain back on this whole revolution. We're going to break down the specific tech, the PGTP, this thing called genotype imputation, and we'll name the companies that are already selling these Embryo Report Cards.
Mm-hmm.
And then we're going to dive deep into the huge ethical and, maybe more importantly, the economic implications of turning heredity from, a lottery into a very selective, very expensive market. This changes everything. It changes the rules of competition and ultimately what it even means to be human in what we're calling a post-luck society.
That's right.
So before we get into the market and all the ethical mess, we really have to get our heads around the technology itself. The leap is just huge. Our sources are very careful to distinguish what genetic testing used to be from what PGTP is doing right now. Can you kind of walk us through that history?
Sure, yeah. Historically, pre-implantation genetic testing, or PGT, was a tool of exclusion, of necessity. It was all about preventing the transfer of an embryo that had a really fatal or severely debilitating disease. It was a process of negative selection. You were just trying to rule out the worst outcomes.
And we're mostly talking about two older types, right? PGTA and PGTM. PGTA is the one that basically everyone who goes through IVF comes across.
Exactly. PGTA. It stands for aneuploidy screening. Aneuploidy just means having the wrong number of chromosomes.
Right.
So this is the test that looks for things like trisomy 21, which causes Down syndrome, or trisomy 13 and 18. The main goal is just viability. You want to make sure the embryo is chromosomally normal, what they call euploid, to give it the best chance of becoming a live birth.
So PGTA is basically a pass-fail. Is the structure okay or not?
It's binary. Precisely. Is it normal or is it abnormal? And if it's abnormal, it's generally not transferred. The risk is just too high.
Yeah.
Then you have the other one, PGTM.
And for monogenic.
Right. monogenic disorders. These are diseases caused by a mutation on a single specific gene.
Like Huntington's or cystic fibrosis?
That's right. And this is usually for couples who already know they're carriers for one of these serious conditions. And again, the logic is all about exclusion. Is this one specific single problem present? Yes or no? If yes, you exclude it. It was all very clear, all about medical necessity.
Okay, so medical necessity, diagnosis, exclusion. That was the old world. Now we get to PGTP. Why is this such a fundamental break from all that?
Because PGTP, and that's for polygenic risks, it's not looking for one broken part. It's a total paradigm shift. You're going from diagnosis to prognosis, and you're going from exclusion to ranking.
We should probably define polygenic because that's the word that changes everything here.
It is. Polygenic just means many genes. So these are traits like your height, your blood pressure, your odds of getting heart disease, even things like educational attainment. They aren't caused by one or two broken genes. They're influenced by thousands, sometimes millions, of tiny genetic variations. They're called SNPs.
And it's not just the genes, right? The environment plays a huge role.
A massive role. So you don't have like one bad gene for heart disease. You have a really complex mix of risk factors spread all across your genome interacting with your life.
And PGTP somehow adds up the effect of all those tiny little factors.
It does, yeah. It uses something called a polygenic risk score, or PRS. And the PRS is, at its heart, a statistical estimate. It takes all those little genetic variations, it weighs them based on how much they're known to contribute to a trait in the wider population, and then it sums them up. It gives you a score, your statistical risk of developing a condition relative to everybody else.
So parents are no longer just getting a yes-no answer on a specific disease. They're being handed a ranked list.
Yeah.
A probabilistic hierarchy, something called an embryo health score.
That's the key metric, the Embryo Health Score, or EHS. That's the product these companies are selling. And it is essentially a composite grade based on all these different risks. It forces parents into the role of optimizers.
Right.
Think about the classic dilemma our sources bring up. You have two embryos. Embryo A is in the 98th percentile risk for breast cancer, but it has a super low risk for schizophrenia. Then you have embryo B, average risk for all diseases.
Yeah.
But it's predicted to be in the bottom 10% for height.
And you have to choose. You're forced to weigh a potential future medical tragedy against what might be a social disadvantage, like being short.
Exactly. The job is no longer just to exclude. It's to optimize. You are selecting a life based on a probability curve. And the moment you start introducing probabilities for desirable traits, even if you're just trying to reduce the risk for type 1 diabetes, you've already crossed the line into enhancement. You're optimizing for the best possible outcome from your batch.
The power of these scores, these PRS algorithms, it all comes down to data. It's not just some clever code. It's a data gold rush. You mentioned GWAS, Genome-Wide Association Studies, is the engine. Where on earth are they getting the data to make these predictions?
The whole foundation rests on massive population biobanks. For a PRS to be accurate, you need huge numbers of people, we're talking hundreds of thousands, who have had their genomes sequenced and linked to their actual life data.
Their phenotypic data.
Exactly. Their medical history, their height, their education level, everything. The statistical power is directly tied to the size of that training population. And the undisputed crown jewel for this kind of research is the UK Biobank.
That's the one with data for 500,000 people in the UK,
Right. 500,000 people, all consenting to have their full genetic sequence linked to their medical records, their lifestyle surveys, even their brain scans. So GWAS combs through this massive data set. It finds correlations between those tiny genetic markers, the SNPs, and traits. It's not finding a height gene.
No.
It's finding thousands of markers that each contribute, a fraction of a millimeter, and it adds them all up to make a prediction that is, frankly, remarkably accurate.
Okay, so the data part seems sorted, but the sources point to a massive technical problem in the lab itself. The DNA sample you get from an embryo is tiny.
And this is where the cost barrier used to be. This is the bottleneck. When you do an embryo biopsy, you're only taking a few cells, maybe 5 to 10, from the outer layer.
Not a lot to work with.
Not at all. That DNA is fragile. When you try to amplify it to get enough to sequence, you introduce all sorts of noise and errors. So getting that deep whole genome sequence you need for a perfect PRS was always incredibly difficult and very, very expensive.
And this is where the big innovation, this imputation trick, comes in, where companies realized they could use the parent's DNA to fill in the gaps.
It's a really ingenious piece of computational genomics. Genotype imputation is the absolute game changer. So instead of struggling to get a perfect sequence from that tiny embryo sample, you do something different. You sequence the parents at really high depth, which is easy and cheap. You just need a saliva or blood sample.
Okay.
Then you sequence the embryo at a very low depth, which is basically what they're already doing for the standard PGTA test anyway.
So you have high-quality parent data, low-quality embryo data. How does the algorithm bridge that gap?
Well, the parental genomes act like a scaffold. The algorithm knows that every piece of the embryo's DNA had to come from one of the two parents. So by looking at the few reliable markers it can see in the embryo's low-quality data, it can statistically figure out which big chunks of chromosome came from the mother and which came from the father.
Wow.
And that allows it to essentially reconstruct the embryo's full, high-quality genome, but virtually.
Yeah.
Some companies even market this as impute PGTA.
And this is where it gets really interesting for you, the listener, because this just crashes the cost. If you are already paying for IVF and PGTA, this PGTP becomes just an add-on, a marginal expense.
That blows the cost barrier wide open. I mean, if you're already going through the emotional and financial costs of IVF, being able to layer on this polygenic screening for maybe a few hundred or a couple $1,000s more, it completely changes the accessibility.
It unlocks the report card.
It unlocks the report card for literally millions of embryos that are sitting in freezers right now all over the world. There's a quote from Jonathan Anomaly of 𝐏𝐻𝐃𝐂𝐀𝐒𝐓 that really nails this. He said, "What people thought they were getting was a down test, but what they were actually getting was a height test, a schizophrenia test. You can unlock that with just simple parental sequencing."
That quote just sums it all up. The pivot from an unintended side effect to an actual commercial product. But before we all rush out to design a perfect baby, we have to talk about the limitations, the validity crisis, as our sources call it.
Absolutely vital. The first and I think most urgent scientific problem is the ancestry bias. It's often called the portability problem.
Meaning
The vast majority of this powerful GWOY data, including that huge UK biobank, is from people of European ancestry.
So if your model is only trained on one group of people, what happens when you try to use it on everyone else?
The accuracy drops. Often, it drops dramatically. The predictive power gets weaker and weaker the more genetically distant you are from that original European training population. So scores that are highly accurate for people with European heritage are significantly less accurate for individuals of, say, African, East Asian, or South Asian descent.
So it could actually make health disparities worse.
That's the fear. Researchers warn that if the tech only really works well for the group that's already the most genetically studied, you're building in an equity gap from the very beginning.
Okay, what's the second big critique? It's about complexity, right? Pleiotropy and trade-offs. You select for one good thing, but the gene for that also does something bad.
This is the risk of optimizing a system we don't fully understand. Pleiotropy just means one gene can affect multiple traits. So if you, for example, ruthlessly select for all the genetic markers linked to high intelligence or educational attainment, you might accidentally be selecting for a higher risk of autism or certain neurological conditions. Or the reverse. If you select against the risk for something like schizophrenia, you might be accidentally selecting against some forms of creativity or cognitive depth. We're using a very blunt instrument on a system of incredible subtlety.
So we have no idea what the long-term ripple effects are. And finally, there's this big academic debate you mentioned. Does this even work when you're comparing siblings from the same parents? The within-family challenge.
That's where the fight has been. The critics argued for a long time that GenRich was just picking up on population stratification. You know, things like rich people tend to live in certain areas and marry each other, so it's a correlation, not causation.
So they were saying that predicting between families, like comparing a Swedish family to a Japanese family, is easy. But PGTP needs to predict within a family. It needs to pick the smartest embryo out of a batch of 10 from the same two parents.
And the critics said, once you control for the shared family environment and background, the predictive power would just collapse.
But that's not what happened.
Well, this is precisely where the startups claim they've made the breakthrough. They're publishing validation studies that they say show they keep a surprisingly large amount of their predictive power for cognitive ability, even when they're just comparing full siblings.
So if that's true,
If those within-family claims hold up, then the practical use of PGTP for maximizing a trait like height or IQ, well, it's scientifically established, even with the other known problems like ancestry bias. The debate has really shifted from if it works to just how well it works.
And that shift from if to how well is the perfect way to get into the marketplace. Because our sources really emphasize that the second the science becomes even remotely viable, that ethical line between avoiding disease and enhancing potential, it just stops being a philosophical problem and becomes a business model.
The market just blows right past that rhetorical checkpoint.
Yeah.
The demand, the parental anxiety driving the demand for enhancement is just enormous. And we really need to look at the main players here because they kind of represent the whole spectrum of the industry's intent.
Let's start with the establishment player, genomic prediction. Their test is called LifeView. They seem to be focused on the medical side of things.
Right. Genomic Prediction, they were founded back in 2017, and they are really the standard bearer for medical risk reduction. They built their brand around the Embryo Health Score, the EHS, and their whole marketing pitch is about reducing the collective risk for a whole suite of major diseases.
Things like diabetes, heart disease.
Exactly. Type 1 and type 2 diabetes, heart disease, breast and prostate cancer, schizophrenia. And their claim is really powerful. They say they can reduce the cumulative lifetime risk for these conditions by up to 40% compared to just picking an embryo at random.
40% that's a massive reduction in disease risk. It's a very compelling medical argument.
It absolutely is. And it lets them keep one foot firmly on the medical side of the line.
Mm-hmm.
But we have to look at their dual function. While they're focusing on disease, they also openly screen for the genetic liability to intellectual disability.
Yeah.
And since intelligence is a continuous polygenic trait, by screening for disability, they are, by definition, operating on the exact same genetic architecture as intelligence maximization. They're just choosing the non-disabled end of the spectrum, which is still a form of selection for cognitive potential.
Okay, now let's go to the other end, the aggressive edge. Companies like 𝐏𝐿𝐴 Genomics, which are they're leaning right into enhancement.
𝐏𝐿𝐴 is much less shy about it. Yeah. Undercover Reporting has detailed their marketing materials pretty explicitly. They openly talk about screening embryos for IQ, for height, for obesity risk. They even call them the naughty traits.
The naughty traits.
The ones that couples really want to optimize but maybe feel they shouldn't ask about. They're not hiding their goal. Their product is designed to create a more competitive child.
And what's their promise on IQ? Because that's the one that taps into every parent's economic anxiety.
Their claims are, well, they're aggressive. The sources document 𝐏𝐿𝐴 executives stating that their methods could lead to an IQ gain of more than 6 points compared to a random selection from the same batch.
6 points, the average IQ is 100. Moving a child from 100 to 106 is a profound advantage.
It is, and they are openly targeting very wealthy couples who are willing to pay a premium. We're talking upwards of $50,000 for high-volume screening.
$50,000 just for the screening. That implies they're pushing clients to create huge numbers of embryos, maybe 100 or more, just to find that one statistical outlier.
That's the model. The financial barrier is part of the product. The only way you can get that +6 IQ point gain is to have a massive pool of sibling embryos to choose from. So this is a service aimed squarely at the ultra-wealthy who can afford multiple IVF cycles, or maybe use egg donors to create these huge batches to maximize their odds of finding that genetic jackpot.
Then you have a company like 𝐏𝐿𝐴, which seems to be positioning itself differently, focusing more on the tech, on that imputation trick.
Right, 𝐏𝐿𝐴 plays the scientific rigor card. They focus on their proprietary imputation tech and their claims about within-family validation. Their approach is more one of radical transparency. They offer tools that let parents simulate the whole range of risks and traits, including intelligence, that are possible from their own genomes.
So they're saying, here's the data, you decide.
Pretty much. And then you have Nucleus Genomics, which seems to be all about the consumer packaging. Nucleus offers this really slick, user-friendly product called Nucleus Embryo. They give you these detailed visualizations of your embryo's future body and physical health. Things like predicted height, male pattern baldness, disease risks. The whole interface looks less like a medical report and more like a sophisticated financial planning dashboard.
It's designed for that data-driven maximizer mindset.
Exactly. The tech is framed as just another tool for proactive life planning.
And this whole shift is being driven by some very clever rhetoric. That slogan from Genomic Prediction, choice over chance, that's incredibly powerful.
It's both manipulative and, I have to say, very effective.
Yeah.
That language immediately reframes a natural pregnancy as being somehow reckless or irresponsible. The message is simple. If you have the power to cut your child's cancer risk by 40% and boost their cognitive potential, Not using that technology starts to feel like a form of parental negligence.
So the natural child becomes the suboptimal child. It puts this immense psychological pressure on any parent who can afford to do IVF.
And you gamify reproduction with these dashboards, giving parents this illusion of control, but at the same time, you're making them responsible for every single outcome. And while, selecting for eye color might seem trivial and height is highly heritable and accurate, the real economic engine here is the IQ frontier. That's what companies are targeting because the financial return on investment is just staggering.
The slippery slope isn't a theory, it's a business plan.
Yeah.
And it's accelerating us toward a very stratified future.
Yep.
Which brings us to the huge societal consequences. If genetic advantage is the product, and the price of admission is tens of thousands of dollars, we are immediately shifting from a society of natural variation to one based on purchased biological quality.
The first and most obvious consequence is that you're entrenching socioeconomic inequality. But now, it's biologically encoded.
Yeah.
Access to this kind of genetic optimization is it's completely out of reach for most families.
Let's just nail down the numbers. You said a single IVF cycle with PGTP is somewhere between $20,000 and $35,000.
And that's the absolute minimum for one cycle that gives you maybe a handful of embryos. To use PGTP for an enhancement to find that +6 IQ point outlier, you can't do that with 10 embryos. You need huge batches.
More cycles.
Multiple egg retrieval cycles, genetic counseling, embryo culturing, the premium scoring services. For the kind of clientele that Heliospect is targeting, the total cost can easily blow past $100,000, maybe even $150,000, especially if they're using egg donors to expand their genetic pool.
And the regulatory system pretty much guarantees this stays a luxury good.
It does. Because PGTP is classified as elective and experimental, it is almost never covered by health insurance. So genetic optimization is reserved for the affluent. And this creates a perfect self-reinforcing feedback loop.
Okay, walk us through that loop.
So the wealthy have financial capital. They use that financial capital to buy access to PGTP, and they purchase a genetic advantage for their kids. That's genetic capital.
Right.
That genetic advantage, higher potential IQ, better health, makes it much more likely that child will have massive financial success in our cognitive economy. That success then creates more financial capital for the next generation to buy the next, even better round of genetic optimization.
You're hardening wealth into biology.
You are creating the GenRich hereditary elite versus the naturals.
The economic logic is just, it's terrifyingly straightforward when you look at the ROI on intelligence. The sources give actual numbers on what one IQ point is worth.
The data is pretty solid on this. A gain of just one IQ point correlates with a 1 to 2.5% increase in permanent income over a lifetime.
Wow.
So if a company's claim of a 6 IQ point gain is even close to accurate, that could translate directly to a 15% increase in lifetime earnings. This isn't some fuzzy wellness claim. This is a cold, hard financial asset that you are purchasing before your child is even conceived.
So that embryo report card is basically a financial planning document, and the consequences go way beyond just one family?
Oh, absolutely. It scales up very quickly to the national level. You get into what some call a cognitive arms race. Economists have shown that the average cognitive ability of a nation's population is a massive predictor of its economic power and innovation.
So if one country starts doing this,
if one nation or one economic bloc gets widespread adoption of PGTP and manages to nudge its average IQ up by even a few points, it could see these non-linear exponential gains in productivity. And that puts incredible pressure on every other nation to do the same, no matter what their ethical qualms are, just to keep up.
And if we zoom out even further, the widespread use of this technology, it threatens the very idea of a social safety net, what philosophers call risk solidarity.
Risk solidarity is that invisible contract that makes insurance and socialized medicine work. We all chip in because we all share the same vulnerability to bad luck, to getting sick, to having an accident. Genetic transparency just shatters that shared vulnerability. Well, if a wealthy family uses PGTP to select a child with almost no genetic risk for diabetes, heart disease, Alzheimer's, they are no longer in the same risk pool as the naturals.
They'll want to opt out of paying for expensive, comprehensive health insurance.
Of course. And this creates a catastrophic information problem. The people with the bad scores, the unengineered, they're forced to buy maximum insurance because they know their risks are higher. The people with the perfect scores will opt out or buy minimal plans. The insurance market collapses because it's only filled with high-risk people.
Which means insurers, to survive, will have to demand access to these scores.
Exactly. Which leads directly to systematic genetic discrimination.
Right.
But on a deeper level, it destroys what's called the veil of ignorance.
Right.
Our willingness to fund things for everyone, public schools, hospitals, comes from this sense that we're all in it together. If the wealthy can just engineer health and talent for their own, they lose that sense of a shared fate. They could start to justify pulling support for public programs for people born with defective genomes because, hey, they chose better for their own kids.
It turns biological quality into a moral justification for inequality.
And it pours gasoline on an existing trend. Assortative mating.
People marrying people like them.
Right. High IQ, high-income people already tend to partner up, which naturally concentrates genetic advantages. PGTP just makes sure that kids get the absolute maximum potential from that already advantaged pairing. It removes the randomness. It hardens class boundaries into biological fact. The so-called meritocracy becomes a hereditary aristocracy, but one that can claim its status is earned because it's written in their DNA.
This commercialization has happened so fast that the legal and regulatory world is just completely lost, creating this global patchwork of rules, this regulatory arbitrage.
It's a fascinating mess where the law is constantly trying to catch up, and savvy patients are actively exploiting the gaps between countries. I mean, look at the UK. They try to hold a very strict ethical line. The 𝐏𝐿FEA, their regulatory body, strictly prohibits PGTP for enhancement. You can only use it for serious inherited diseases.
But we know that UK patients are getting these scores for enhancement anyway. How are they getting around the 𝐏𝐿FEA?
Through a loophole in the GDPR, the Data Protection Regulation. That rule guarantees patients a right to their own medical data. So UK patients who are doing standard IVF just request the raw genomic data from their embryo biopsies.
And then what?
They send that raw data file digitally across the ocean to a US company like Harrisite or Nucleus Genomics.
And the U.S. company, operating under looser rules, just runs the numbers and sends back the report card.
Exactly. The U.S. company generates the rankings. Embryo A is best for cognition. And then the UK patient goes back to their regulated UK clinic and just tells the doctor which embryo to transfer, saying it's their personal preference.
Wow.
The 𝐏𝐿FEA is basically powerless. They can regulate what their clinics do, but they can't stop a patient from accessing and using their own genetic data with a foreign company. The wealthy are just shopping for the most convenient regulations.
And meanwhile, the U.S. is still basically the Wild West.
It's a very light-touch approach here, mostly because PGTP often gets classified as a laboratory-developed test, an LDT. That designation lets it skip the really rigorous FDA review that drugs or medical devices have to go through, so companies can market it directly to clinics and to consumers with these vague claims about wellness or risk reduction and face very little oversight. It lets the enhancement industry just blossom.
And beyond regulation, the legal system is already, in a subtle way, putting a price tag on a defective child through some of its legal precedents.
This is one of the most sobering parts of this. You see it really clearly in wrongful birth lawsuits. In a few places, parents have successfully sued doctors who failed to diagnose a serious genetic defect, like Down syndrome, during prenatal screening. And those successful lawsuits, they establish a really troubling legal principle.
Which is?
The implication is that parents have a legal right to expect a healthy child, or at least to get the information they need to terminate a pregnancy if it's not. The birth of a disabled child, if information was mishandled, is legally seen as a compensable injury.
That validates the idea that a genome has a market value.
It does, and it sets a worrying precedent for what constitutes a minimum level of genetic quality.
Right.
And then you had the Zytex sperm donor lawsuits, which took it even further, basically treating the genome like a consumer product that's under warranty.
That case was a landmark.
It really was. Parents sued the Zytex sperm bank because the donor they chose had lied about his background. He claimed he had an IQ of 160 and hid that he had schizophrenia. The court let the case move forward as consumer fraud. The legal system essentially confirmed that the information about the child's genetic potential was a consumer good. And if the product specs, the IQ, the mental health, didn't match the brochure, the company was on the hook for damages.
It completely solidifies the idea that biological traits are commodities.
Yes.
And before we get to the core ethics of this, we have to mention that the huge gaps in GINA, the Genetic Information Non-Discrimination Act.
Right. GINA was passed in 2008, and it's important, but it's full of holes. It protects you from genetic discrimination in health insurance and in employment, but the gaps are massive, and they're highly relevant to this GenRich scenario.
So where are the gaps?
GINA does not cover life insurance, disability insurance, or long-term care insurance. These are huge financial products. And in these areas, insurers are explicitly allowed to use your genetic test results, including a PGTP score, to set your premiums or even deny you coverage.
So a child who was selected via PGTP for low cancer risk could get a great life insurance rate, but a natural child who happens to have a high risk for heart disease could be priced out of the market.
Correct. And even more, GINA does not apply to education or housing. This is the critical Gattaca loophole. A private institution, an elite private school, a university, could potentially ask for polygenic scores for educational attainment as part of their admissions process, just like they ask for SAT scores now. The law is just not ready for this.
Okay, let's pivot to the really deep moral objection, the one articulated by the philosopher Michael Sandel. It goes beyond fairness and safety, and it gets at what he calls the loss of giftedness.
Sandel argues that the deepest problem with genetic enhancement isn't that it's unfair, but that it reflects this deep human hubris, this drive for mastery. And in doing so, it destroys our appreciation for the giftedness of life. A child, he says, should be received as a gift, something you accept with humility.
But when you treat a child as a product of design, the parent becomes responsible for every single outcome.
And that creates this crushing new burden of anxiety.
Yeah.
If your child struggles in math, you can't just shrug and say, well, that's just how they are. The question in the back of your mind is, was it their fault or was it my fault for not picking the embryo with the better math genes?
It creates this impossible standard of hyperparenting.
And it removes that necessary humility of just accepting what life gives you. Genetic luck, for all its cruelty, it teaches us humility. It teaches us shared vulnerability. Replacing that luck with choice invites this intense hubris for the successful. They can credit their great genes and their parents' great choices, and this profound humiliation for the unsuccessful. The natural can't just blame bad luck anymore. They have to see themselves as biologically inferior by design.
And what about the idea of liberal eugenics? Proponents say PGTP is a voluntary free choice, totally different from the coercive state eugenics of the 20th century.
The counter-argument is that the cumulative effect of millions of individual free choices can be just as coercive as any state mandate. If the entire elite class is selecting for higher IQ and better health, the freedom to choose a natural birth quickly disappears.
Because you're choosing to put your child at a disadvantage.
You are. The parent who chooses not to enhance is effectively choosing to handicap their child in this global cognitive arms race. The freedom to choose becomes the obligation to enhance.
It's the ultimate ethical trap of the market. Your moral choice to accept nature translates into a real-world, measurable disadvantage for your child. We've established that PGTP is here, but right now it offers, relatively modest gains. A couple centimeters in height, maybe 2.5 IQ points from picking the best of 10 embryos. That limitation is key.
Right.
The gains are constrained by the parent's own genes.
That is the current bottleneck. You can only pick the best cards from the deck that your two genomes can shuffle together. But the true technological game changer, the thing that removes this biological constraint and really accelerates us toward a full-blown Gattaca scenario, is the convergence of PGTP with a radical new technology, in vitro gametogenesis, or IVG.
Okay, what is IVG, and why does combining it with PGTP create such an exponential leap?
IVG is the ability to create sperm and eggs from somatic cells, like a simple skin cell in a petri dish. If this tech becomes routine, you're no longer limited by a woman's ovarian reserve or how many eggs she can produce in one IVF cycle.
So instead of the 10 or 15 embryos a couple might get from one cycle, IVG could generate thousands.
Thousands, or even tens of thousands of unique, viable embryos from a single couple. This is what's called the multiplier effect. If you're picking the best out of 10, your gains are small. But if you can generate 10,000 embryos to choose from, you can find the extreme statistical outliers.
Wow.
You could select an embryo that is 3 or even 4 standard deviations above the population average for traits like height or intelligence, simply because you've expanded the sample size exponentially.
That's the mechanism for actual biological divergence. You stop talking about small gains and start talking about a completely separate evolutionary track.
Precisely. If the GenRich elite use IVG and PGTP to consistently select traits that are way above the mean, they could eventually become reproductively isolated from the naturals. They have effectively hijacked evolution, and this fractures the whole idea of a shared human community.
The sources raise this truly profound question. If one group of humans engineers itself to be significantly healthier, smarter, and longer-lived, do we get to a point where we have to redefine human rights for different species of human?
The philosophical question is, do they even share a common biological fate anymore? If the engineered class is practically immune to the diseases that still plague the natural class, the bonds of solidarity, of shared humanity, they snap. The convergence of IVG and PGTP is the final technological step toward a biological schism.
So this deep dive really confirms this unsettling thesis. Gattaca isn't a warning anymore. It's a commercial reality, and it's being sold to us today as preventative health and responsible parenting. The technology, PGTP, is here, and it's providing pretty accurate scores for disease, for height, and increasingly for intelligence.
And the barrier is purely financial and ethical, not scientific. The price tag from $20,000 to over $150,000, it limits access to a tiny wealthy elite. And it guarantees that the economic inequalities we already have will be compounded with permanent, hereditary, biological advantages.
And this whole shift is happening quietly, one IVF cycle at a time, driven by very understandable parental love and anxiety. But when you add it all up, it's building a deep biological stratification. We saw the economic incentives, that 1 to 2.5% income boost for every IQ point, and the claimed 6-point advantage from startups like 𝐏𝐿𝐴Spect.
Validity becomes a score on a report, potential becomes a purchasable asset, and the unengineered human is at risk of becoming a biologically, legally, and economically disadvantaged second-class citizen. We've really reached the end of genetic innocence.
The new normal is replacing the humble acceptance of chance with the often brutal illusion of control. And that illusion brings with it a new and relentless kind of parental anxiety.
And this is the final thought we want to leave you with, something for you to really think about as we enter this post-luck society. When genetic selection becomes an obligation, and that comforting scapegoat of bad luck is taken away, what does it mean for society, and what does it mean for a child when parents can no longer blame random chance for their child's shortcomings, but instead have to face that agonizing question, did I choose the wrong embryo?